Yes, good evening. My name is Henry Senyonjo. We are here to present MLOps. First of all, MLOps stands for Machine Learning Operations. And machine learning operations, this refers to a set of practices and that automate and simplify machine learning workflows and deployments. Yeah, so the relevance of MLOps is that it is crucial for efficient machine learning model deployment, monitoring, and management for real-world applications, just like our model. Yes. So these are the different trends and techniques influencing our project. We have automated machine learning pipeline, and this one just streamlines our workflow and reducing manual effort and also accelerating the deployment process. Then we have model versioning and tracking. This one just helps us to keep track of the different versions of our model and the associated data, which facilitates collaboration and ensuring model transparency. Then we have AI ethics and governance. This one just helps us to make sure that we are in line with the ethical considerations while developing our model. Then continuous integration, that one helps us to make sure that we deploy updates and improvements to our model rapidly. Then real-time monitoring and feedback, that one is just for monitoring our model. Then the application of DevOps, data ops, and the heavy and light ML ops. We have DevOps just combines development of IT operations, automate and streamline the software development cycle. And applying this DevOps will help to the machine learning model using version control, then automated testing and continuous integration and deployment. Then we have data ops, which is used for improving the quality of the data. Just data ops is just data engineer, integrates data engineering and operations to improve the quality and availability of the data. And then heavy ML ops, this one is just complex infrastructure and extensive automation of the machine learning models. So heavy ML ops offers high scalability and reliability. And then we have light MLOps. This one focuses on simplicity and agility with fewer automation layers. So the difference is that heavy MLOps is more resource intensive, while light MLOps takes fewer resources to come up with the model. And then we shall go straight to the code. Let my friend will come in from here.
My name is Drake, and I'll take you through the code. So to track like machine learning model training, we've used MLflow. MLflow, this is our MLOps like website that is used to track like the training of the models. So it can track, like it's used for auto logging, that is like different logs of your model, the metrics, the signatures, and then different parameters. So here, so for us to know like which model has worked better than the other, we need to track everything, need to track the model training, and this is done by MLflow. So first, we begin by installing MLflow. This is done before running other pods, before training, so that we can track everything. So it also tracks like the data sets used. So first we use pip install MLflow inside our like Google Colab notebook. Then you see take some time to install. Then next, we have to set up the MLflow tracking URL. And again, we have to first start an experiment, that is by giving it an experiment name. Then we start the running. So first we have to import some necessary modules that are gonna be working, that will be used first, like reading the files, reading the zipped files, like installing TensorFlow, and then TensorFlow working with MLflow, like for us to start on the training. Then next we have to access the data set. This one was stored on our Google Drive, then accessed using the RR module. Then it is stored inside the train directorate, and then the validation directorate. The train directorate will be used to train the model, and then validation to check for the model performance, and then validate the model. So we do model resizing. This is inside like data pre-processing. We do some model augmentation, some data augmentation to improve on the quality of the data, and then make sure that we are gonna get like good results for the training. Then to start on the ML flow, we'll have to first start running the ML flow before starting on the training. That's why you have ML flow dot start. Then we have 10 classes. Then we start on the model. Our model used EfficientNet B0. Then everything will be tracked by this ML flow, and then every result is sent. That is, every logs are sent to the website so that we can see everything, we can visualize everything, and then compare which model worked better than the other. So here is the dashboard of ML flow, like having tracked everything. So we have the tomato, that is the experiment we saved. And again, like different flows, we've not shown most of the things here because we had only saved a little of them, but everything we do is tracked inside this MLflow website connected. So first of all, again, before going here, we have to first create an account on our website that gave us the tokens we had to provide inside the code so that we could connect to MLflow. Then after there, we did model training. We used 8 epochs, and then we gained an accuracy of 0.8579 after all the training. So my friend will take you from there again.
Yes, Senyonja again. So in this slide here, we were training the model, and we trained the model using 8 epochs. And this line of code, which starts with history equals model.fit, was the line of code that was used to train the model using those 8 epochs. And then down here are the results of the training data. And here we have the accuracy. We ended up with an accuracy of 85%. And then here, this line of code was checking for the performance of the model. We first imported the matplot library, which was used to come up with a histogram that was used to visualize the performance of the model. And this is the visualization of the performance. The red line, the red curve indicates the training loss of the model, and then the blue curve indicated that the accuracy, like the training accuracy, and we can see that the accuracy went on increasing as the epochs went on increasing. Yeah. So this here is the GitHub repository of our project. You can see the name of the project. We used the EfficientNet model, come up with this classification model. In the GitHub repository, we also have the README file plus the requirements file, and then the model files. Yeah. Thank you for listening. That was our presentation. Have a good day, sir.